In this chapter, we're going to be studying statistics. In this lesson, we're going to look at cumulative grouped continuous data.
Okay, everybody, so now we're going to take a look at cumulative grouped continuous data. Oh, it's a great name. So cumulative frequency is basically just a running total. That's all it is. Okay, we give it a fancy name, but that's all it is running total here. So, for example, the cumulative frequency distribution table for the weights of 120 male football players is shown below. So here we've got our class intervals, okay, of weights, and then we're going to identify the frequency or the number of players that fall into each one of those class intervals. So remember, weight is a continuous variable, okay? But it helps us understand it if we group them together and sort of treat it like more of a discrete thing, so that we have a discrete number of people in that category. Now, what we do over here with our cumulative frequency is, so the first class interval's got 2 people in it. So what we're doing at this point here is, how many people do we have total? Maybe I should write it like this. I'll grab a sheet of paper here. Well, okay. Here. Grab one like this. So what we're basically doing here is, the cumulative frequency is how many people do we have up to this point? So there's 3 people in this category. So how many people do we have up to this point? Well, that's 5. Up to this point. Up to this point, okay? So up to 75, how many do we have there? Well, a total of 31. Up to 80, how many do we have? 50. So there's a big jump there. Anyway, that's what we're doing here with this cumulative frequency graph. Cumulative frequency, which we can then plot. Okay. So a cumulative frequency curve can be drawn for the group data. It can be obtained by plotting the cumulative frequency against the corresponding upper class boundary. So what we're doing is we're plotting this here. I'll do it like this. We're plotting this right here, okay, on the independent variable, with this value right there on the dependent variable. So this is always how many people do we have up to this point right here, and we get this graph right here. And it's called, okay, this is a cumulative frequency curve, but you're going to see sometimes it's called an ogive, or I've heard people call it an ogive, which looks a little weird there, but anyway. For those of you that chemistry, you're going to recognize this as probably something like a titration curve. And yeah, that's right. Okay, but this is what we call our cumulative frequency curve. Okay, now we want to introduce a couple of new ideas. They're not very complicated though. Percentiles and quartiles. So what a percentile is, okay, it's the score below which a certain percentage of the data lies. Okay, and so the example that we give here is, let's say that in some sort of context, whatever, you are in the 85th percentile. That means that you are above 85% of the population. Often you'll see this done when babies are born and they're weighed or they're measured. They'll measure the length of the baby, and they'll say that this baby is in, like, let's say the 60th percentile, which means this baby is longer than 60% of newborn babies. Just to give you a sense of how that works there. Now, that being said, bear in mind that let's say the longest baby that has ever been recorded there is not in the 100th percentile. Just so that you catch that, that's not possible, because it's the percentage of the group that person is above. Well, that person's still part of the group, and they can't be above themselves. So you can never be in the 100th percentile. Now, that being said, once you understand what a percentile is, then we have quartiles. And what quartiles are is when we break up the data into quarters. So the lower quartile, called Q1, is the 25th percentile. So we're looking for the spot in the group where this person right here is, let's say, larger than 25% of the group. Okay, the median is going to be considered Q2, the 50th percentile. That person right there is larger than 50% of the population. Now, when you think about that a little bit, you're going to see a bit of a problem with that, because if you're in the 50th percentile, it means you're slightly above 50% of the group, which means you're in that upper 50%, so you can't have exactly 50% larger than you. And I get that. But you're going to see in a moment here that the discrepancy is pretty small. When you're talking about a large group here, usually that difference is almost negligible. The upper quartile, what we call Q3, is the 75th percentile. So at that point here, where are you in the group so that you're big enough to be larger than 75% of the population? And then we've got this other thing here, this interquartile range here, IQR. And that is the difference between the third quartile and the first quartile. That should represent 50% of the population. Okay, so basically what's going on here is you've got this line, let's say, here's the beginning part, here's the end part. Then you've got this Q1. So this is our minimum, let's say. We've got our Q1 here. We've got our median. I don't know. The median can be anywhere. Let's say the median is here. And then you've got this Q3 here. So we know that this is, sorry, and then I should identify your max. Whoops. Your max way up here. Well, I know that I'm going to have 50% here. I know that I'm going to have 50% here. But then what they're saying is this should also be 50% right there. Okay? Just how I break up the data here. And that gives you a sense of how the data is being spread out a little bit. Okay? Now, using the example above, the cumulative frequency curve has effectively placed the data in order. Okay? Because it's this cumulative frequency and we identify as we go down through all of our class intervals with an increasing value there. It's already placed in order. So we should be able to read off the median and the quartiles and any other percentile you want. So let's take a quick look at this one here. To find the median, first of all, so take a look at this. The median is halfway along the list of data. So in this particular case, we know that there's 120 data values. Now, first of all, we were told that. But secondly, we can go down through our class intervals here, and when we look at our cumulative frequency at the very end, we get 120. So I know there's 120 people here, or objects being analyzed here. So that means the median point is going to be 60. We just take that, divide by 2. Now I know, and you're going to see that here, I know that technically that's not how that would work, right? It would be 120 plus 1 divided by 2, which is going to be 60.5. But we're just going to go down and just divide that by 2 to get make that the 60th term is going to be the median. And like we say right here, in large populations, that little discrepancy that's going to pop up is usually so small that it's not worth kind of getting worried about. So don't worry about that. Then what we do is we take a horizontal line drawn from 60 to the vertical from the vertical axis on the curve here, and then we're going to go across and then drop down to the x-axis there. Now that might sound a little bit weird, so I'm going to show you the diagram here in a second. So here's that ogive that we had a few minutes ago. To get our median, what we do is we go across here at 60. So we went 120 divided by 2 to 60, and we're going to go across here to my ogive. And then I'm going to drop right down here. This is going to be the median weight. Right there, wherever I hit. Okay? That's what they're saying here. So a horizontal line drawn from 60 to the curve and then drawn down to the horizontal axis, that's going to be our median, and that is about 82 kilograms. If you want to find the upper 2 quartiles, well, then you got to proceed like this. What's 75% of 120? Well, it's going to be 90. Okay? So what we want to do here is we want to go up to 90. This is our Q3. We're going to go across. We're going to drop down. And it's just a hair over 80. Oh, sorry. No, I think in this case, we're interpreting that as just being on 85. So that right there is going to be my Q3. To get the lower quartile, we're simply going to take 25% of that 120. And the 25% is going to be, 25% of 120 is going to be 30. And then we come across here. Oh, you're not seeing that, sorry. We come across here at 30. Where we hit the curve, we drop down. And that's a little less than 75. I think what did we identify that as? 74. So there's our our lower quartile, our Q1. Okay, and just by looking at how it's spread out from our minimum value here out to our maximum value, and then we can see where the first quartile is. So this is 25%, this is 25%, so 25, 25, 25%, and then 25%. Well, this gives us a sense of how the data is spread out, where it's clustered and where it's more widely distributed, okay? So we can determine a range for the whole data set, and then what we do here is we look at the difference between the two quartiles. That's the interquartile range, and in this case that's going to be 11. So the distance from here to here is 11, and notice that that carries with it 50% of the data. So that gives us some information once again about the spread of the data in this group. Okay, now this kind of leads us to something called a box and whisker plot. And I've tried in the last a couple of segments here to kind of hint that this is where we were going. But it's a diagrammatic way of showing the median and the quartiles and the relationship between them, okay? So here's an example of a box and whisker plot. So you'll notice that it's that line that I had drawn there before. I've got the least, this is our min. Out here is our max. Then what we do is we mark off the lower quartile, the median, and the upper quartile. So this is our Q1, our median, which is our Q2, and then here's our Q3. But then what we do is we just connect them. Okay? So basically, this is 25% of the data. This is 25% of the data. This is 25% of the data, and so is this right here. Okay? And so this gives us a sense of how spread out. These two regions right here are fairly equally spread out, but that third 25% right here, just above the median, that's spread out a little bit larger, and then it's more compact right there. So it gives us a sense of how the data is looking, okay? Now, if we look at the football players, this is what that box and whisker plot would look like, okay? And in fact, if I go back to what I had drawn down here, basically all I really had to do here was to connect that line that I had drawn there, draw the little lines there, and then make the boxes. That's what this is right here. So here's our 25%, here's our 25%, there's our median, 25% and 25%. So that first 25% and the last 25%, they're quite spread out, but notice that middle 50% is quite compact, okay? So there's a cluster there in the center. Typically, okay, then when we talk about the box and whisker plots here, we have what we call a 5-number summary here. We've got the minimum value, number 1, the lower quartile, the median, the upper quartile, and then the maximum value, which is basically just 1, 2, 3, 4, 5, those 5 numbers there. These numbers come from the one variable statistic calculation on the calculator. And again, they should be used for the ungrouped data only here. Now, when you go to the bottom, remember when you do one variable statistics, that calculation, you got to go down to the bottom there, and then this whole thing is set right up for you. Okay, so you can just pull all that information right out of there. Now, before we go and we take a look at actually using the calculator here, here's a bit of information that you need to know. When data values are far away from the mean, we call them outliers. So every once in a while you'll have a set of data, and then there will be a data value in there that's really out of whack with the rest of the data. So just to give you an idea here, this maximum here, this part right here, this has got 25% of the data. But it is entirely possible that, let's say that most of those data values are right here, and then there's one data value that's just way out there, just that one. But that's what's pulling that maximum way out there and making it look like there's this huge spread. So there is a little bit of a limitation to how useful this is. It does give us a fairly good idea in general, but if there are outliers, and that works down here as well, if there's outliers that are way out of keeping with the rest of the data, well, then maybe we're not getting a clear image of this, okay? Because that data value right there, that's way out of whack here. That is not typically what we're seeing in the group here. So, because it's difficult to make a judgment about what constitutes far away, okay, so what is it that makes an outlier here? I mean, this is my outlier right now if the data's all there, but if I have the data spread out to there, is that still an outlier? If it's out to there, is that still an outlier? If it's out to there, is that still an outlier? I mean, how far away does it have to be? And that is a kind of a judgment call. So what we do here is we have kind of a standard way of dealing with it here. And here's the thing that you got to know here. Data values that are more than 1.5 times the interquartile range above Q3 or below Q1 are outliers. So this is that magic way of testing that, okay? So in the above example that we've been using with the football players here, the interquartile range was 11, okay? Q1, the first quartile was 74, Q3 was 85. So let's take this. If you take 74 and subtract 1.5 times 11, we get 57.5. This is the low bound, okay? So if I go up here, 57.5, on my graph here, this is my low bound, right around, 57.5 is going to be somewhere right here. That's my low bound. Anything beyond here, this is going to be considered outlier. On the other hand, 85 plus 1.5 times 11 is going to be 101.5. 101.5, that's going to be up here. Anything above that, between there and there, those are going to be considered outliers. So anywhere here is considered outlier. And that's kind of our standard way of dealing with that. Okay, I hope that makes sense. Okay, there have been questions about these, what constitutes an outlier. There have been questions like that that have shown up on the IB exams, so it's worth considering. Okay, now let's have a look at using the calculator to draw a box and whisker plot. It's kind of cool that it'll do this. So we need a set of numbers here. So the set of numbers we're going to use is this one right here. Okay, and first thing we do is we enter it in. So now I have already kind of gone through and done that. So stat, edit, and I've already put the data in that list once. So you don't have to watch me do that. Now, once that's done, we're going to go to our second. We're going to go to our second statistical plot here. So second, y equals. Now, my stat plot is already turned on because of some work that we've done in a previous lesson. So, but I'm going to go through now, and I want to turn on the box and whisker plot. And if you go down there, the box and whisker plot is the one that's second from the end there. And if you take a look at that, you'll recognize that shape. Okay, so press enter to choose that. Now, in the case that we've got right here, the data was not entered as a frequency chart. Okay, the data is all in list 1 here. So my frequency, each one of those entries in there is just worth 1. So my frequency is 1. Okay. Now, I don't mind it being blue, whatever. So over here, we're being told to, if I press zoom number 9, so what is, if I go to zoom number 9 is zoom stat. And so what the calculator does is it goes to the statistical information that you've entered and chooses appropriate window settings. And when, whoops, shiny there. When I press enter, boom, I get that box and whisker plot, which is kind of awesome here. Now, you can actually use it too. If you if you press trace, see, I tried to say that in one word to economize. If you press trace, then what happens here, and I'll press trace right now, press trace, it drops me right on the median. And I can use my arrows to go to the minimum value, Q1, there's the median, Q3, and the maximum value right there. So I can go through and explore the 5 values associated with the box and whisker plot here. Now, On the other hand, if you've got a frequency table in there, all you'd have to do is make sure that when you calculated this, that you had that list 2 in there as the frequency so that it would calculate it properly. And then it'll do the proper adjustment to create the appropriate box and whisker plot. Okay, now let's use the graphing calculator to draw the cumulative frequency, to draw cumulative frequency polygons. Okay, so we're going to do those ogives on the graphic display calculator. So here's our data. Okay, so we've got our class intervals right there, and then we've got the frequencies. So we're going to enter the class boundaries into L1. Now this is what I'm going to do here. I'm going to enter 0 as the first one, even though there's nothing below 0. But that's going to give me a starting point. I'm going to have the point 0, 0 in there. Then I'm going to enter 10, 20, 30, 40, and so on. And then I'm going to associate the frequencies. So I'll associate 5 with the 10, 10 with the 20, 15 with the 30, and so on. Okay? So my frequencies are going to go into list 2. Okay, then what we're going to do is I'm going to move my cursor up to L3. I'm going to show you something that the calculator can do here. So once I've got the representatives of the class intervals there, and you'll notice right at the top there I've got the 0 and I've got a 0 right there. Basically that just kind of anchors my graph on the origin. Now I'm going to go up. I'm going to go up to L3. Okay, because I want to show you what the calculator can do. It's going to save me a little bit of work here. So once I've done that, I like this. I'm going to press second stat ops 6 enter. Oh boy. Okay, so second stat ops down to number 6, and down to number 6 is this cumulative sum. Okay, cumulative sum. That's what that stands for. I'm going to press enter, and so that's going to put the cumulative sum right there. And what I want it to do is I want it to add up list 2. Okay, so as soon as I put list 2 in there and I'm going to press enter, boom, what it does, we'll kind of zoom in on that, make sure you can see that. What it's going to do there is it's going to add up all of those values there as you go down. So it's going to give you the cumulative data there. Good. Whoa, wrong way. Now, so now that we've got that cumulative frequency table, now we can go back into our stat plot, just like it says right here. So I'll go second y equals. My stat plot's already on. But what I got to do is I got to go over here, and I want to choose this one right here. I want to choose this what we're going to end up calling a frequency polygon. Okay, and I'll explain what it's doing here in just a second. And we're going to choose that. We have got our frequency list, or the cumulative frequency, that's in list 3. So it's going to be second number 3 is going to put that at 3 there. So now the calculator is going to look at list 1 and list 3 here. And what the calculator is going to do, what this tells it to do is it's going to build these little bar graphs. Okay, it's going to build these bars, and it's going to take the midpoint of the top, and it's just going to connect the dots there. So now I'm going to press zoom number 9. And there is my ogive. Now, that every little dot that you're seeing there is really the top of a bar, like in the histogram, the bar there. And it's putting a dot in the center there and then connecting the dots from the 0, 0 all the way up to the end. Now, we can use this, what we're seeing right here in the calculator, we can use that to actually find the median, to find Q1, to find Q3. But it's not super easy. Okay, it's not a really super easy thing to do here. So I'm going to show you the calculator, and I'm going to show you, kind of explain what we're doing here. Now, our total frequency, if I go trace here and go all the way up to the top here, we've got 102, okay, 102 data values in there. So to get the median, I'm just going to divide that by 2, and that's going to give me the number 51. So what I'm going to do here is I'm going to go across here at 51. Okay? And in fact, maybe what I'll do here is I'll actually just put y equals 51 across there, and it's going to draw a line across. And then I'm going to press trace. And I want to go up to that line. if I just press trace and let it go, it'll jump from dot to dot to dot here on my ogive. What I want to do is I want to get as close as I can to the curve to see what it is, okay, to see what the x value is. Now, when I look at my x value there, okay, it looks like it's roughly 39.5. I can actually do a little bit better. Because I'm going to press zoom here, and I'm going to use zoom box. And you may or may not have ever used this before, but once you use zoom box here, what that allows you to do is I move the cursor over a little bit. I'm going to press enter. I'm going to move the cursor down a little bit. And I'm going to make sure that it has just boxed the thing that I want to zoom in on, and then it zooms right in. Now I'm going to press trace again. Make sure I move up or down, because the default is going to be to go on the ogive, so I'll press down. And now I'm going to move that over and take a look at what my x value is. Now, I can zoom in on that a few times if I want to. Okay, I can zoom in basically as much as I need to get as close as I want. But it's looking to me like, yeah, okay, looks like my median there is going to be roughly 39.5 or 39.6. Okay, that would be the median that I'm looking for. Now, before we go on and talk a little bit about this here, just that last little procedure that I showed you would work really well if you're finding any of the quartiles, by the way, not just the median. But anyway, here we go. So using the graphic display calculator effectively, so when data is a discrete set of numbers, grouped or ungrouped, the graphic display calculator will give accurate values for all calculations, cumulative frequency curves, and box plots. So you can put those in there, right? You can do the cumulative frequency graph, you can do the box plots. We just showed you how to do that. When continuous data is grouped into intervals, which is what we've spent a fair bit of time looking at here, the graphic display calculator assumes that all values in a given interval are equal to the class mid value. Okay, so typically we're going from some left side over to some right side. Well, the calculator is going to use that mid value to represent that class. It actually kind of makes sense there. So calculating the mean standard deviation are going to give you only approximate answers when you're dealing with continuous data that you're grouping. When drawing cumulative frequency curves, the graphic display calculator will join the points using straight lines rather than a smooth curve. Now, if you're doing this by hand, you're probably going to put a kind of a smooth curve in there, so you're going to anticipate the curvature. But the calculator doesn't, so that's again something that you have to consider when you're looking for the median or the quartiles, or any percentile for that matter. Okay, that the calculator is going to use those straight lines, and so that maybe isn't the best approximation to what the data is actually doing. When drawing box plots, the graphic display calculator will use class mid values for calculations rather than the cumulative frequency values. The median and quartile values using the box and whisker plots are not the same values as those obtained with the cumulative frequency curve. Okay, they're just not going to be. If you want more accurate answers, values obtained from the cumulative frequency graph should be used to draw box plots by hand. That's something to consider there, okay? Anyway, hopefully that makes sense, and that gives you a little bit of confidence using the calculator to do some of this analysis.